All right, MSDOSX, welcome back for some more iPhone programming today. Today, the lecture, I'm going to keep this lecture pretty short. It's again about Interface Builder and about designing UIs for, this case, iOS. What you'll see is it's pretty much the same, which is basically what the lecture is going to be. It's basically saying it's pretty much the same except for these few things that are different. So it's pretty cool. Are you going to work again today? Okay, so let's start by making that same slider UI, but for iPhone. And I'll show you some of what we have in here. No, not that one, actually. Get out of here, please. Okay. Okay, so let's make a new simple view-based application. So what this is going to do is it's going to give me a window and it's going to give me a view, and I'm just going to put some controls into that view. You'll notice that Xcode will allow you to choose whether you want the application to target iPad, iPhone, which also includes iPod Touch, or be universal and run on all devices. I'll talk a little bit toward the end about some of the considerations you need to do when you're doing universal. I'm just going to do iPhone because it's easy. But you can make a single executable that runs on all devices. Okay. So we can see the project. To begin with, we get a lot of the same things that we get with a Mac project. We get an app delegate. We get a view controller, which we'll talk about in a few weeks. But the idea is it's a special controller that knows it's managing a view. Nothing too complicated. And we also we have a nib file, which is just going to contain the view. The main window gets constructed automatically for you, and pretty much for the most part you don't have to worry about it. It'll give you a view, and then you can just draw into that view. So let's. Oh my God, that's tiny. And again, you'll see that we have the same springs and struts that we have on OS X. It's worth noting that auto layout is not available for iOS. That's a OS X Lion exclusive thing. But let's just drag these same controls from before. So we have a label so that we'll put the value in it, and then a slider. And again, we get the same blue guidelines telling us that we're adhering to the human interface guidelines. And let's customize this label so that it goes from 0 to 100, and it starts at 50. And we'll have it send events continuously. So again, pretty straightforward. There's a lot. You'll notice that the set of available objects on iOS is a lot more limited. There's just because the screen is small, and because there's a lot of differences in how touch interfaces should work. You just are not going to have the same level of flexibility with your controls, and so that your design should be as simple as possible. Okay, so that's that. So again, this is all going to kind of really smack of the same that we had from last time. But again, views can specify their auto resizing behavior, which doesn't make a whole lot of sense on iPhone because you can't resize the window. But what it is important for is how to handle auto rotations. If you want your application to be able to be viewed in whatever orientation the user wants, then if you don't specify any auto resizing properties, if you just use the defaults, it will just remain anchored wherever you put it. So you want to specify some auto resize behavior, so that way when the rotation changes and you allow it, the views that you put inside of your main view will just automatically resize themselves and rearrange themselves so that they fit into this new, differently sized view. For the most part, if you just simply by setting these auto resize properties, you'll get the behavior you want. But there are cases where you need to do some custom overriding of the layout behavior, and there's methods to do that. I'm not going to talk about them today, but there are ways to do that custom if you don't like what the auto resize behavior gives you. Again, in order to talk to the code, in order for the code to refer back to the interface, we have outlets and actions again. They are pretty much the same as on Mac. An outlet is exactly the same. You create a reference in code to some interface object, you specify it as an IB outlet, and then you'll be able to hook it up in Interface Builder. Actions are a little bit more interesting in iOS, and also so on Mac, for one thing, the sender parameter to an action method is always required. On Mac, every object when it calls an action will always pass itself in as the parameter. On iOS, you can actually omit the sender parameter, so that way you don't know who sent the message. You just know that some object sent the message, which is useful if you only ever have one button calling this one method. There's really no need for the sender because you know which one is sending it. So if you don't want the sender, you don't need to take it. What's really cool about controls on iOS is that they can send multiple different actions. So on OS 10, every control has one action. So a button has the button got clicked action, and that's it. And then that's when it sends an action. On iPhone, I'm going to cover that in a couple slides. But on iPhone, you have a lot more actions that you can specify. And rather than have a separate set target, set action pair of methods like on Mac, iOS you have a single method called add target action for control events. So target and action, those are pretty easy. The target is who you want to send the message to, just like on Mac. The action, again, is a selector, just like on Mac. But what's interesting is there's this control events field. And what's cool about this is, you'll see how this works in a couple slides, but the idea is that's actually a bit mask. So if there's multiple events that you want to listen for to send events on, you can bitwise OR all those together. So here's a couple of example calls. So suppose we have a button, and I want to send one event when the user taps down in the button, and if the user decides, that's slightly misnamed. If they touch up, I'll go over these in a little bit more, but there's this event, UI control event touch up inside, which is the event that gets sent when the user's touch comes up within the bounds of the control. And that's usually where you want I'm committing this button press, the user meant to press this button, so let's do whatever the button is supposed to do. So I have this method tap down, which again, I'm sorry, it's poorly named, but it should be like tap up or something. But the idea is, this is the method that gets called when a button tap is successful, but we can also, if the user taps it and decides, oh wait, I don't want to tap on this, and they drag their finger away, we want them to be able to not tap on the button. So there's another event, touch canceled, or touch up outside, that will get called in one of those two cases. And in that case, we can call a different method. These are all the different control events that you can possibly have. So we have touch down, which is pretty obvious. It's just when the touch goes down onto the object. There's touch down repeat, so that's useful if you want to capture a double tap or a triple tap. You'll get that for every additional touch down that it determines as part of the same touch event, but is an actual distinct touch. There's some time delay if it determines that you like tap, wait, tap. Those will get sent separately, but if you do like a double tap real quick, it'll be able to tell those as touch repeats. Then there's drag inside, so if you have a control that you're listening for some sort of drag event, so that's pretty obvious. Drag outside may seem a little bit weird, because how would you ever drag outside of a control? The reason they have that is, suppose you start by touching inside of some control, and then you move your finger outside and continue to drag. It'll send drag outside all that time that you're dragging, but you're not actually inside of the control, and you haven't let your finger up yet. The iPod app uses this a lot. So the iPod has the scrubber at the top for you to be able to scrub through the song, and you'll notice that you don't have to keep your finger inside of the control in order to keep scrubbing. In fact, in recent builds of iOS, the further down the screen you pull, the slower your scrub rate will be. So they allow you to be able to continue to scrub even if you're not actually inside of the control. Drag enter and drag exit are when a drag event becomes inside the bounds, and when a drag event becomes outside the bounds. Touch up inside is when the touch comes up and it's within the bounds of the control. Touch up outside is when the touch comes up and it's not within the control. And presumably if I touch inside one control and then I touch outside some other control, I'm not going to get touch up inside on that other control because that's not where the touch started. But it is where it ends, so I would get touch up outside for the other control. Does that make sense? That's a little bit weird, right? But hopefully that makes a little sense. And then last, there's event touch cancel, which doesn't get called a lot, but I believe if you drag off the screen entirely, you'll get touch cancel. You'll also get touch cancel if the user's finger is down when, say, they get a phone call or a text message, and that touch now doesn't make sense because there's some other interface being shown. I believe that also gets sent because it has to do with the way scrolling gets handled. So figuring out if the user's trying to scroll is actually sort of a complicated operation, because there's a touch down, a drag, and a touch up. But what if inside of that scroll view there's something that listens for touches? How do we know if a touch down is touching the control or starting to scroll? So basically the way it works is it'll assume that you're scrolling, and then if it doesn't move, it will send canceled to whoever's listening for the scroll event, so that way they know, wait, we didn't actually scroll. That's one other reason where canceled will get called. There's also an event for when the value changes. So this is useful for sliders. When you slide the slider, its value gets changed. There are others, but I can't think of them off the top of my head. And then there's several for text editing. So you have some text field or some text view. You can begin editing. You can start to change the text. You end editing. End on exit. What does that get called? That might get called when I think that gets called when the keyboard gets dismissed. So you're not explicitly ending the. I forget exactly. The documentation obviously will explain this. And you notice that the values of these are chosen so that you can bitwise OR these together and not have the values collide. So all the touch events are like, 0001, 0010, 100, 1000, 10,000. So that way, when you bitwise OR them together, the bits will all just they won't collide with each other. They'll just be able to fill in more slots, and the framework code will be able to interpret this number this basically what some integer that's going to get, and figure out which one of these events that you actually want to be listening for, which is pretty cool. So you can see in this lower example here, I've bitwise OR'd up outside and canceled. So those that'll evaluate to whatever 100 and 10,000 or 100,000 or something to add up to. But anyway, the whole point is that the number 8-bit is on and the number 3-bit is on, so the framework code knows that those are the two events that you're interested in. And those can be arbitrarily long. And then lastly, they have a bunch for just kind of groups for different groups of events. So if you want to just do something for every touch event, you can do all touch events. There's all editing events, application reserved. You can actually define your own custom control events, I believe, and that's what that one is for. And then there's ones that are reserved for the system. And then there's all events, which is literally all events. You very rarely want to have a control operate on all events, because that will intercept a lot of the system events that you probably, and you'll get some really unexpected behavior. Okay, so let's actually hook together this slider application. It's gonna look pretty much the same as what I did on Mac. The main difference is that in this nib that we were given, rather than having a reference to the app delegate, we have a reference to this view controller object, which again we'll talk about these later. But the idea it's a controller that knows it's controlling a view. So that's where I'm going to put all the logic in here. So let's first create an action so that when the slider's value changes, we call this action so that we know that the value got updated. So let's add a method to this view controller. And it's going to be of what return type? IB action, which again is just void, but and I'm going to, just to show you, I'm going to omit. Oh, I don't want that actually. I'm going to omit the sender because we really don't need it for this, because there's the one control that's sending the action. So let's call it slider changed. Okay, and you'll notice that Xcode has given me a lot of skeleton code, none of which I'm going to need, but that's okay. Okay, so slider changed, and again, let's for now just log it out to the console so that we can see what we have. Actually, no, sorry, I actually am going to have this taken a parameter because I don't really need an explicit. If I didn't have the parameter, then I would also need a reference to that slider, right? Otherwise, how would I know where the slider is? So I'm going to have it pass itself in so that way I know what the slider is that changed. Oh, not NS slider. What am I talking about? UI slider. So yeah, pretty much all the classes are going to be the same, except that on iOS, UIKit, which is the equivalent of AppKit for iPhone, everything is prefixed with UI as opposed to NS. There's a few things that are missing and a few things that it has AppKit doesn't, but for the most part, they're pretty much the same. So let's do that. Slider, and have that be a float, and we'll just ask the slider for its value. Alright, and then we will just go into the nib, and we can control click from the slider. No, not that. Control click from the slider to the file's owner, which is of class slider view controller. And we can see that we have this event slider changed. Now notice that I didn't actually specify what event to send that on. Xcode or Interface Builder is smart enough to know kind of what the default event is for all the different controls. So the logical event for a slider is when the slider's value changed. We can actually inspect that if we go up here to the connections panel, and you can see now there's a whole bunch of sent events, and you can send in a different event or a different action for every one of these events, and you can see it defaulted to value changed. So I also could have set this up manually and just gone value changed, drag the file's owner, and choose slider changed. And you can do this for all the different events that you're interested in. But for this case, we're just interested in when the value of the slider changes. Okay, so let's hope I did that right. Oh boy. So, for those of you who haven't seen this before, this is the iOS simulator. It offers the ability to have an iPhone, a Retina iPhone, or an iPad. It can be a little slow at times, and might be a bit of work to get to work on these lab machines. It has been in the past. We might get lucky and not have it be a problem. Anyway, so we can drag the slider, and we can see that we're getting an event for every time the slider value changes, and we're just logging that value. Okay, so now let's add a little bit more logic to update the value of the label when we get those events. So let's create a reference in our code to that label object. So I'm going to create a UI label, but I'm going to make it an IB outlet, right? So that way Interface Builder can see that label. And it's a UI label, we'll call it label. And then over in Interface Builder, again, there's a lot of ways I can do this. I can either control drag from the label to the file's owner. Can I really not?
You don't have to make it a property?
No, sorry, I did it backwards. I don't have to make it a property. It's fairly common to make it a property. You'll see a lot of people make these properties. They tend to do it for two reasons. One, if you make it a property, then Interface Builder isn't directly modifying the instance variable, which is considered safer, so that way it modifies the variable through method calls. It also allows you to specify the memory management behavior more clearly. So this is actually pretty common and probably a better way to do this. So I don't really need the IB outlet there. You can mix and match those IB outlets; it'll figure it out no matter how you do it. So now let's synthesize that. And since I set the memory management property to be retain, meaning that every time that label gets set, it calls retain on it. That means when I get deallocated, I'm done with that label and therefore need to release it. So I'm going to release it in dealloc. Oh, except default projects have arc turned on. Hang on. No. I am not comfortable with arc yet. I don't trust it. Okay, so now we can go back into our nib and encode this reference, so we can either control drag from file's owner to the label. And again, why are you telling me you can do it with different types? That's weird. Oh, because it doesn't. Anyway, oh, because there's another outlet that it has. It has a view outlet. Okay. Anyway, so we can choose the label outlet. Again, we could also drag this from the connections panel over here. Drag from the label to the label. And here again, notice that it knows what type label is. It knows it's a label, so I can't assign it to the slider or to the main view, just to anything of type UI label. Okay, so now we have that reference. Now all we need to do is update the text of that label every time the slider's value changed. And unlike on Mac, controls don't have an implicit, at least the text controls don't have a set float value or set integer value. They have set string value, and that's it. Or it might be set text. Label. Yeah, so I'm just going to set the text on the label, make a quick format string. Have it take in that float value and just have it pass into that slider value. Is that everybody cool with that? Okay, I'm gonna take that as a yes. And I drag the slider and the value changes. And again, it's cutting off because I made the label really small. But that's a small fix. Any questions about that? Again, it should look pretty much the same as what you saw on Mac. You just have a different array of controls at your disposal, and the sender parameter, if you want, you can omit it. But other than that, it's pretty much the same. So again, like on Mac, equivalently on iOS, we have UI application, which is the natural analog to NS application, which it manages the main run loop for you, and it will. Oh, I should change that. There aren't any. Well, there isn't a mouse on iOS, but in particular, it's going to wait. It's going to mostly wait for touch events. Keyboard is done a little bit different because there is no hardware keyboard for the most part. Even when you plug in a hardware keyboard, I believe it's treated like it's a software keyboard to iOS. But again, it waits for these events from the touch, mostly from touches, and then sends those events to the objects that they're underneath, basically. And again, it's the instance that owns the main window. Again, you don't really deal with UI application that much. Usually, you only deal with with the application delegate interface to it. And then it will call methods on that delegate when certain events in the application's lifecycle happens, like did launch, did enter background, did return from background, and so on, and did quit prior to iOS 4. Like on Mac, we have views, and the superclass of all views is UI view. Again, analogous to NS view, pretty much the same. Again, wait a few lectures, and we'll talk about doing custom views and how to subclass views and do drawing in views. But again, they can contain subviews, and they can all have this programmatic layout of hierarchy. Again, there's a window class. It manages a window frame, and unlike on Mac, you usually only have one, your main one. iOS itself manages quite a few windows. For example, the status bar is actually a separate window. And you can make independent windows, and it's a little bit weird. It's fairly uncommon. The main reason I did one once is I wrote an app that I wanted to have a bug submit button, and I wanted to have that bug submit button visible everywhere in the application. And it didn't make a lot of sense to have to make that bug button on every single view in my application, so I thought, I'll just make it a window and put it at the very front, so that way it's always visible. For the most part, you never need to make a window. The project will give you a window when you start, and that's it. You just put things in the window and call it a day. So again, we have a similar looking view hierarchy. We have a window. There is no notion of a content view of a window. Just again, because there's only one view, there's only one window. A window is basically a special view in some sense. So it has subviews, just like view does. And views have subviews, and then that main view can also have some other subviews. Does that make sense? Again, it should look pretty much the same. So like I mentioned, we have UI controls, which again are the analogous to NS control. They're the superclass for text fields and for buttons. But unlike on Mac, there is no implicit concept of value of control, so you can't just say float value, int value, bool value on on anything. For the most part, they all have their own custom methods that they implement. Because most of the controls on iOS are a lot simpler, and because there's less real estate, it doesn't make a lot of sense to put a lot of very complicated controls. It makes more sense to have a lot of very simple controls, because you don't have that much room, and people's fingers take up space on the screen. So on that note, I wanted to talk a little bit about kind of some special design considerations for when you're designing for a touch interface. So this is going to seem like a really obvious fact, but if you're designing for a touchscreen, you need to take into account the fact that the user will be touching the screen, which sounds kind of dumb. But in particular, that means that wherever the user is touching, they can't see that part of the screen anymore. So if you have a very, very small control, as soon as they try to touch it, they're no longer sure if they're actually touching it because they can't see it anymore. So that's why all the standard controls are a lot larger on iOS. So you want to make sure that that if you make any custom ones, that you don't make them too small, because otherwise the user won't be able to know if they successfully touch it, because when they try to touch it, they cover it up. This is a problem we call the fat finger problem, because people's fingers are pretty big relative to, say, a cursor. Again, since fingers are large, there's sort of an inherent little error bound on what actual XY coordinate is chosen for where the touch happens. You might think that the system will just return to you like a cluster of points that are currently being touched. You don't need to worry about that. The iOS determines, it does some averaging, I would imagine, and it determines an individual XY coordinate in floating point value of where it is currently registering a touch. And so, because there's this small amount of error, if you have two controls that are too close together, the user is going to probably have a hard time figuring out which one they're actually touching, because their finger, because there's this little bit of error. So you don't want to have your controls too close to each other, because the user will struggle to figure out which one they're actually touching. Okay, so a few points on making your app universal. So again, we can make an application that runs on all devices, not just iPhone and iPod Touch family, and not just the iPad family, though you can do that if you want. Some cynics say that developers do that to make more money, because then they can sell one version of each. Users like it better, though, when you have one application that just runs on all their devices. They buy it once, they download it once, and all the devices have it, and it just runs. Which is really nice for the users. It's a little bit of work for us. So some things to consider when you're designing a universal application. In particular, when you're designing your views, if your view is created in Interface Builder, you must have a nib for the iPhone family and a nib for the iPad family. There's no such thing as a universal nib. Nib files are, by default, a certain size, and I think you can actually probably coerce it to use one that doesn't match. But generally, it makes the most sense for you to have one nib for iPad and one nib for iPhone, so that way you can design those differently and make sure that those experiences are really tailored to the device. Because with iPad, you have a lot more screen real estate, which I didn't really realize how important that was until I started designing my first iPad app. You have a lot more space. You can do a lot more with that much more space. So it's often the case that the interface on iPad is actually totally different, and so it makes a lot of sense to have a separate nib for that. On the other side, if your view is created dynamically in code, which we'll show you how to do that soon, that code should be dynamic and should be able to generate, ideally it should be able to generate an arbitrary size board, view. But there are times when hard coding values is necessary. I understand that. So one way to get around that is to have conditional code pass, and I'll show you in a few slides some macros that you can use to determine what device you're on. So that way, when you get to a certain point in your code and you need to branch based on if you're on an iPhone or an iPad, you can do that branch. View controllers, we'll talk about these more next week, I believe, toward the end of next week. But again, they're just a controller that manages a view. It's pretty common to have a view controller for an iPad version and another view controller for the iPhone version, because, again, a lot of times the interface is very different. So having one giant conglomeration of a controller doesn't make a lot of sense, because it's just the interface is going to be different to that controller. It also is it's a lot less of a headache on you if you just have to keep track of, okay, this is for iPad, this is for iPhone, and I control this. There's a lot less condition checking you have to do. You just make separate ones, and then all you have to do is load the right one when you need it. It can be done in one object. It's hard. It's going to have a lot of branching in your code. So I wouldn't highly recommend it. Sort of on top of that, do you have a question?
Do you have separate view controllers when you're making a universal app? Do you want separate view controllers, or the view controller code actually takes it into account?
You can do it either way. it's often easier on your brain to do things in separate view controllers, just because you can especially if the interface, if the two interfaces are really different. Having those be in the same object is hard because you have to keep track of which one you're on. And have a lot of there's a lot of branching checks that you need to do. You can do it in one object if the interfaces are similar enough and it makes sense to do it in one object. Go ahead. So on top of having two device families, we're increasingly having, at least with so far we just have iPhone 4, although everybody is guessing that the next iPad is going to also have a Retina display. But so the iPhone 4 has double the pixel density in both directions compared to the 3G and the 3GS. And what's kind of cool is that UIKit actually abstracts the pixels away from you, and you do all of your geometry in terms of points. So the iPhone 4 screen and the iPhone 3GS screen have the same number of points, but the iPhone 4 has twice as many pixels. So you can, in some sense, you can say an iPhone 4 pixel is a 2x2, or not, sorry, an iPhone 4 point is really 2x2 pixels. So it's a nice abstraction, so that way you don't have to really worry about the actual pixel density on your device. You just know how many points it has, and it does all the right rendering and drawing for you. So when if you're dealing with images for your Retina display, for the Retina display, really should be at double resolution, so that way they look better and actually get drawn correctly. And if you don't, they'll look fuzzy. And there's a convention that if you have an image called image.png, and because Apple recommends using PNG for all of your image files because it is nice and vectory. If you have a ping, then the Retina display version should be image at 2x, and that's sufficiently ingrained into the framework code that there's a method UI image named, which you've seen NS image, the equivalent on NS image in the Asteroids lab. It works the same way, but what's really cool is you don't have to tell it, if I'm on an iPhone 4, look for image at 2x. If I'm not on an iPhone 4, look for image.png. If you just say image name, image.png, it knows if you're on an iPhone 4, it will look for an at 2x version if you have it. So that way you don't have to actually do conditional code branching for if you're on a different device. It just figures it out for you. And if it doesn't have it, then it just uses the default one. So that's really nice. It eliminates a lot of conditional code because you don't have to check if you're on a Retina display. It just grabs the image that makes the most sense. So there are times, though, where you're going to need conditional code. UIKit does a lot for you, but it can't do everything, and there are a lot of cases when you're doing something really custom that you need to know which device you're on. And there's on iPhone and iPad, there is a macro that tells you that will return either interface idiom pad or interface idiom phone that will tell you if I'm on a phone right now or if I'm on an iPad right now. This is just a C-style macro, so just call it basically like it's a function, and it will return that, and you can use equal on that. So it's pretty common to see something like if UI user interface idiom equal pad something else, some block of code else the other block of code for doing the iPhone stuff. There's also a method on the UI screen class called scale that tells you the scale factor between pixels and points. So you can use that to determine if you're on a Retina display or not. Notice that Apple's done this in a general way, so that way they can have an even higher pixel density in the future. It's not is Retina or not is Retina. It's just the scale value. So that can tell you if you need to do some custom scaling of everything, how much to scale by. Any questions on that? Okay, so the rest of this is pretty much the same as what we've seen before. Again, delegation, as we'll see next Monday, is a really powerful pattern in Cocoa, and it comes up a lot. And the canonical example for now for you guys is the application delegate, which Xcode provides for you by default when you make a new project. It listens for when the application starts, a method gets called on the app delegate. When the application goes into the background state, since iOS 4, it sends a method on that. When it returns from background state, when it resigns active, when it regains active, all those methods get called on it. Prior to iOS 4, it would call terminate when the user quits. It doesn't really quit anymore. It just kind of since iOS 4, everything just kind of goes into the background. There really isn't the concept of quitting anymore. But those are the methods that get called on your delegate, on the application delegate. So again, the application lifecycle is pretty much the same. It starts up, the application starts up, it loads in the main window nib, which I think my project, which actually Xcode 4 does away with and just creates a window programmatically for you. But if you have a main window nib, it loads that. Otherwise, it just creates the window from code and then loads it up into the view on screen. Then it just waits in this run loop where it waits for an event, processes the event, and just keeps doing that until the application goes into the background state or terminates. So again, we call application did finish launching when the application launches, and will terminate prior to iOS 4 when it will terminate. Or will enter background, or did enter background, for example, since iOS 4. Okay, any questions? Like I said, it's pretty much the same. Just what controls you have available are a little bit different, a little bit simpler, and you need to think a little bit more carefully about designing your user interface because you have a lot less real estate. Cool?